Welcome back to the deep dive. Today, we're going deep inside, exploring something truly amazing about your own body. It's kind of like hidden plumbing, this incredible network of, well, arterial bypass roads and shortcuts.
hmm
Have you ever really stopped to think about the sheer elegance of the engineering inside you? How it all keeps flowing? We're going to explore the body's ingenious resilience, its built-in backup plans, and how it keeps critical things running pretty much no matter what.
Right. And these specific connections, these internal pathways, have a name: vascular anastomoses.
Hmm.
Essentially, they're natural links or detours between blood vessels. And what makes them so remarkable is their absolutely vital role. They provide alternative routes for blood flow, critical redundancies. So this makes sure that your vital organs, your tissues, they keep getting the oxygen and nutrients they need, even if, say, one pathway gets blocked or injured. You can think of them as the body's own built-in emergency bypass system. Really quite efficient.
The body's emergency bypass. I like that. That's a great way to picture it. And what's really interesting is how specific some of these systems are. So for this deep dive, our mission really is to look closely at some key examples. We're focusing specifically on vascular anastomoses in the pelvic region, drawing right from the sources you've shared. And these examples, I think, really reveal the elegant, almost clear engineering hidden inside all of us. By the end, you should have a much clearer picture of these crucial connections, a real appreciation for this built-in wisdom without needing, a medical degree.
Okay, so let's unpack this. Our first example, it's like a triple play, creating this really robust network around, well, a very important organ. We're talking about the rectum here.
Yeah.
Its blood supply is just a fantastic example of physiological redundancy.
It really is. The brilliance here is this major anastomosis involving three key arterial players. First, you've got the superior rectal artery. Now, that comes off the inferior mesenteric artery, the IMA, we usually call it, which supplies a big part of the gut.
Then this connects with the middle rectal artery, which is a branch of the internal iliac artery, the IIA, that's a major pelvic artery.
Right, the IIA.
And then, to make the network even stronger, these two link up with the inferior rectal artery. And that one branches off the pudendal artery deeper in the pelvis. It's less about memorizing all the names, and more about seeing the three different arterial systems from different major origins all come together for this one organ.
So, stepping back a bit, what does this intricate setup, this triple connection, actually mean for the rectum's blood supply? Why does the rectum get this kind of VIP treatment with such redundant blood flow?
Well, it's not just about backup. It really shows how the body prioritizes even these foundational functions. The robustness here is key.
Yeah.
The rectum has a critical ongoing job, right? Waste elimination. And the body clearly wants that to run smoothly, uninterrupted. Having these multiple pathways means if one artery gets partially blocked, maybe due to disease or an injury, blood can still get to the rectum through the other connections.
Oh, I see.
It drastically minimizes the risk of tissue damage or failure. It ensures stability for a process that just has to keep going. It's like the body insists, this show must go on.
That's fascinating. It really highlights the body's priorities, doesn't it? Even for the parts we don't often think about. But this ingenuity doesn't stop there.
Yeah.
If we move up a bit towards the lower back and pelvis, there's another really interesting connection, another bridge, you could say, offering similar kinds of redundancy. We're talking about the lumbar iliolumbar bridge.
Exactly. This is another key connection, this time between the lumbar arteries and the iliolumbar artery. So the lumbar arteries, there's a series of them, they supply muscles in the back wall of your abdomen, the spinal cord, structures in your lower back,
Okay.
and the iliolumbar artery. That branches off the internal iliac, the IA again, and it supplies muscles and bones deeper in the pelvis and the lower back area itself. This anastomosis creates a direct link between these two systems, a pretty robust one.
So what's the aha moment with this one? What does this connection specifically protect against? Does it, stop problems spreading?
Well, connecting into the bigger picture, this link is really vital for keeping blood flow consistent to structures in both the lower back and parts of the pelvis. It provides crucial collateral circulation, which just means, an alternative route for blood if the main supply is compromised.
A detour, essentially.
Precisely. Imagine, maybe because of an injury or a clot or even just arterial narrowing as we age, the main blood flow to a lower back muscle is reduced. This lumbar iliolumbar connection acts like a natural bypass route. It lets blood reroute, keep supplying those tissues, preventing potential pain, weakness, or even tissue death. It's another really powerful example of the body's design for resilience. Building in backups not just for organs, but for our structure too.
It's amazing how the body plans for these what-ifs. Okay, now this next connection, it has this really dramatic name, almost poetic. And that name alone tells you it's important to understand, not just because it's useful, but because it has potential implications, especially clinically. Let's talk about the corona mortis connection, linking the obturator and inferior epigastric arteries.
Yes, the corona mortis. It translates from Latin as crown of death. It sounds quite dramatic, doesn't it?
Yeah.
Anatomically, it's an anastomosis, a direct link between the obturator artery, which usually handles blood supply to thigh muscles, the adductors and parts of the hip,
Okay.
and the inferior epigastric artery, which supplies the front wall of the abdomen. Now, this connection isn't in everyone, but it exists to varying degrees in a fair chunk of the population.
Crown of death. That's intense. So why such a heavy name? What's the real significance here, balancing its benefits and, well, the obvious risks implied by the name?
Right? It really highlights this fascinating trade-off in anatomical design.
Mhm.
You get efficiency, but sometimes potential risk comes with it. On one hand, the corona mortis is a potentially vital alternative pathway. If the main obturator artery gets blocked, maybe trauma, this connection could help keep blood flowing to the leg or pelvis. Could save tissue.
So it's a good backup.
It can be. But its location is the issue. That's where the name comes from. It often runs very close to, or even right across, anatomical spots surgeons need to access during certain groin or pelvic operations. Think hernia repairs, for example.
Ah, right.
If this vessel, this anastomosis, is accidentally cut during surgery, well, it can bleed a lot. And controlling that bleeding quickly can be very difficult.
I see.
So it's a classic double-edged sword. It's a useful redundancy, but also a known surgical hazard that surgeons need to be extremely aware of. It makes you wonder, about how the body prioritizes adaptation, even if it introduces a little bit of vulnerability sometimes.
That's a perfect illustration of that balance. Okay, finally, let's look at one more connection. This one is absolutely crucial for the female reproductive system. It showcases another ingenious dual supply system, really underlining how the body supports, well, life itself.
Yes.
Yeah.
Here we're talking about the anastomosis between the uterine artery and the ovarian artery. The uterine artery, that's a major branch off the internal iliac artery, the IIA again.
Yeah.
Its main job is supplying the uterus, obviously vital for pregnancy.
Right.
The ovarian artery, though, that one comes directly off the aorta, the body's main artery, much higher up in the abdomen. It supplies the ovaries and also parts of the fallopian tubes. This connection creates this really rich, dynamic network, linking these two quite separate major vessels.
So why is this connection, this dual supply from different origins, so critical for the uterus and ovaries specifically? What does it protect or ensure?
What's truly remarkable here is just how incredibly robust and redundant the blood supply becomes because of this connection. These organs, the uterus and ovaries, they're central to reproduction. And the processes involve things like ovulation, menstruation, and especially supporting a pregnancy. They demand a huge amount of consistent, rich blood flow.
Makes sense.
This anastomosis provides that double security blanket, if you will. It means if there's some compromise to one of the main arteries, the other one can immediately help pick up the slack, ensuring that blood flow stays ample and continuous.
So it's vital for fertility and pregnancy.
Absolutely. This redundancy is essential for maintaining the health and the very complex functions of these organs throughout a woman's reproductive life. It safeguards fertility, supports development. It's a really clear sign of how heavily the body invests in protecting the functions needed for reproduction, for, ultimately, the continuation of the species.
It really is inspiring, isn't it, when you uncover these intricate, often quite surprising ways our bodies are built with these backups, these redundancies. So as we wrap up this deep dive, just take a moment to think about these pelvic vascular anastomoses we've discussed. They're just a few examples, sure, but they powerfully illustrate this incredible engineering within you, making sure that even under stress, life-sustaining blood flow carries on. It's like having this perfectly coordinated emergency response system running silently inside you all the time.
Absolutely. And these specific examples, they really underscore a key idea. Understanding these connections gives us a bigger picture. They vividly highlight the body's innate ability to adapt, to survive, to keep complex functions going through these smart, interconnected internal networks. It's not just about the individual pipes, is it? It's how they link up, support each other, creating a whole resilient system. It's a masterclass in physiological stability.
So what does this all mean for you listening right now, carrying this whole universe of hidden resilience inside you? Well, it means every breath, every heartbeat, really, every moment is supported by these fundamental, elegant connections. Appreciating this, I think, helps us grasp the deeper workings of life itself, not just as parts, but as this dynamic, interconnected, self-sustaining marvel. It's a great reminder of the amazing wisdom just built into our biology. And as you go about your day, here's something to maybe mull over. If our bodies are packed with such elegant natural bypass systems, all designed to ensure survival and function even under pressure, what can that teach us about building resilience and redundancy into the systems we design in our own lives? Whether that's personal habits, maybe professional workflows, or even bigger things like societal structures. Think about those hidden networks. How vital are those alternative connections when the main path gets challenged? Keep exploring the deep dives within yourself and the world around you.